In this video, we're going to be looking at the integration or finding the antiderivative of e to the x, sine x, and cos x. And then also when you have variations such as e to the 3x plus 2, like 4e to the 3x, you have to find the antiderivative of that. So we're going to look at these three, and then at the end we'll look at some questions, then we'll have a worked example of how you can solve and find the antiderivative of these three different types of functions. So we'll begin with e to the x. So if you remember with differentiation, when you diff e to the x, you just get e to the x. So that implies when we anti-diff e to the x dx, we're just going to get e to the x and plus c, because there could have been a constant there. However, with the basic function, the e to the x, it remains the same. So the power remains the same. However, if we then put some other terms in it, so let's say e to the 4x dx, what does this equal? Well, it has to equal e to the 4x, so the power has to remain the same. And the reason for the power remaining the same is that when you diffed, no matter what happens when you diffed, the power remained constant. So the power is the same on both sides, then when you anti-diff, the power is still going to remain the same. So if e to the 4x, and this is equal to e to the 4x, I'm also going to have this plus c. But it's anything else. We're going to have 1 divided by 4. And if you diff this, you can see that the 4 comes down. So when we diff, we get whatever this point is up here, and we diff it, and we times it. So that's why we need that 1 over whatever the diff is here, and that's because it will counteract when you diff it, and you'll get the same solution as you had here. So you can just remember it by going, like previous examples we had, or previous integrations we looked at, you have 1 over the derivative here. So you have 1 over 4, because the derivative of 4x, so d dx of 4x, is equal to 4. Then we can generalize this to e to the gx. So gx can be any function. This is equal to 1 over the derivative of gx, e to the gx, so once again the power remains the same, and then plus c. So the important thing is that what is in the power, and then if you're deriving it, then you can times it down and finding the derivative. However, if you're finding the antiderivative, it's 1 over whatever this derivative is up here in the power. So what about sine x and cos x? Well, when we have sine x, so if we want to find the antiderivative of sine x, we have the integral of sine x dx. This is going to be equal to cos x plus c. Because when you go from when you diff, you go from sine to cos, and also from cos to sine. So we have cos here. However, when we diff cos, we get negative sine. So if we want to go d dx of cos x, this is equal to negative sine x. So at the moment, this equation isn't right, because if we diff this cos x, we're not going to get sine x, we're going to get negative sine x. So what we have to do is we have to put a negative here. And so that's really important. So if you remembered before, when we went diff from sine to cos, that was positive cos. When we diff from cos to sine, it was negative sine. But now when we anti-diff sine, it's going to be negative cos. When we anti-diff cos, it's going to be positive sine. So they've switched around. And the reason for this is, if you look at this and try and understand it, it'll make more sense. Because effectively when we're diffing, we're going from this side to that side. But now with diffing, we're going the other way. So that's why when you have cos, you needed this, it's a negative sign. When you had a positive sign, to get a positive sign, you had to have a negative cos, because the two negatives would cancel. So generalizing this to sine gx. So if we have sine gx dx, this is equal to negative 1, so the negative there, and then g dash x. So just like with e dx, we have to divide by the derivative of whatever's inside the sine x. Then it'll be cos gx. So once again, with ex, whatever's inside remains the same in both. However, we have to divide by the derivative, and you have to be mainly careful, or always remember the plus c, but especially careful in this sine and cos about where the negative is. So you think about derivative, it's sine positive cos, cos a negative sine, but it's the other way around when you anti-diff. So then with cos, what's cos going to equal? So if you anti-diff with cos gx dx, this is equal to 1 over g dash x sine gx plus c. And that's because when we diff sine x, we're going to get positive cos x. So we don't need a negative sign to cancel anything. So looking at these two questions. So pause the video, have a go, and then remember what are the properties of integrals to make these questions possibly a bit easier for you to solve. Starting off with this side. So firstly, I'll take the negative 3 out, because that's a constant. We get e to the negative 4x plus 2 dx. This is equal to negative 3, and then it's 1 over the derivative of negative 4x plus 2, which is negative 4, and the power remains the same. So that's really important. And then there's going to be a plus c. So then there'll be a plus c out there. And this is equal to 3 on 4 e to the negative 4x plus 2. And the negatives cancel and we get 3 on 4. And that's the solution. Now if you're a bit confused about why the plus c is outside rather than inside, you can put it inside and then you times it by a constant. But any constant times another constant will just give you a constant. And at the moment we don't know what that constant is, so we just represent it. So as long as it stays a constant, that's fine. So you don't have to worry. If you put it inside and then you times it by negative 3, that's fine. You can just let it equal another constant if you want to make it a bit easier for calculations. But what I mean, so if you have a constant, times it by negative 3, it's still not going to have an x or a y term in it. It's still going to have be an actual integer number. But yeah. So what about if we go on to the next question? So we have to find the antiderivative. We have the integral of negative 3 sine 2x, and this is with respect to x. So once again, I'll take out negative 3, and I'll get sine 2x dx. This is equal to negative 3, 1 over 2, cos 2x. However, as we're going from cos and we need to get to positive sign, we need the negative here. And then there'll be a plus c there as well. So just I'll write it out a bit clearer. Plus c. So once again, the negatives cancel and we get 3 on 2 cos 2x plus c. And in both cases, the 2x remains the same, the negative 4x plus 2 remains the same. However, you just have to be careful about 1 divided by whatever the derivative is, and especially for sine and cos, is there going to be a negative or is it going to be positive?